In today's microbiological and biomedical research laboratories, procedures are conducted that can generate infectious aerosols and biohazards. These aerosols must be contained to protect laboratory personnel as well as the environment from exposure. Other procedures require a sterile environment with non-turbulent airflow so that cells and other cultures will not be contaminated while they're being handled. Both of these procedures can be performed safely in a biohazard safety cabinet using proper working techniques. This training program will describe the proper procedures to follow when working a biosafety cabinet, including how to plan your work in the biosafety cabinet and what to wear, how to prepare the cabinet, as well as the materials and equipment for your work, how to minimize the release of aerosols, disruptions to the cabinet airflow, and the contamination of your work, how to clean up spills during work, how to remove materials from the work zone, and procedures to shut down the cabinet and to remove protective clothing. Prior to starting work, you must carefully plan the steps to be used in your procedure. List all the items required for your work, including equipment, cultures, media, and other materials. Your list will help you prepare necessary items before starting work. Depending on the work being conducted and your laboratory's standard operating procedure, you should wear appropriate personnel protective equipment. Before donning your protective clothing, wash your hands thoroughly with germicidal soap. When conducting low-risk work, wear a long-sleeve lab coat and rubber gloves. Ensure gloves cover the cuffs of the lab coat. For higher risk work, such as Biosafety Level 2+ and Biosafety Level 3 work, a solid front long sleeve gown and 2 pairs of gloves are more appropriate. Make sure the top gloves cover the gown's cuffs. There should be no exposed skin. Gloves and garments will protect you from the agents you work with and will also keep you from contaminating the cabinet work zone, your cultures, and other research materials with skin flora. If a germicidal UV lamp is being used, you must deactivate the lamp as soon as you enter the laboratory. Raise the front sliding sash to the opening height and turn on the fluorescent lights. Ensure that air intake and exhaust areas of the cabinet are free of obstructions. Start the cabinet blower and allow the cabinet to purge for 3 to 5 minutes. This will remove the airborne contaminants from the work zone and stabilize the cabinet airflow. Adjust the height of your lab chair so that your armpits are approximately level with the bottom of the front sliding sash. This will ensure that your face is protected by the front sash while giving you plenty of room to work. Wipe down the interior work zone surfaces with an appropriate disinfectant, including the front air grill, with a suitable disinfectant such as 70% isopropyl alcohol. The most effective disinfectant will depend on the organisms manipulated and the work conducted in the biosafety cabinet. Wipe down the external surface of items with disinfectant and load the cabinet work zone with all the items you will need for your work. Check the list you have made earlier on. Make sure you have everything you need before you start. Nothing should be taken out of or put in the biosafety cabinet once you begin working. Pay special attention to the front air grill, which must not be covered as illustrated here. Disruption to the inflow of air into the cabinet will compromise the cabinet performance. The cabinet work zone should not be overloaded. The biosafety cabinet work zone should be divided between 3 areas: so that you have a clean area, a working area, and a contaminated area within the work zone. These areas must be located to minimize movement of clean items over contaminated items and vice versa. Place your waste container in the contaminated area. Place your working equipment and specimens in the working area, and your supplies should be located in the clean area. Transfer materials from the clean side through the work area to the contaminated side. Never use sharp instruments, particularly needles and syringes in the biosafety cabinet. Avoid moving your hands in and out of the biosafety cabinet. When working in a biosafety cabinet, use slow and deliberate movements. Avoid side-to-side arm movements as much as possible. Enter and exit the cabinet from straight on. Biosafety cabinets will control aerosols, but will not eliminate contact transfer. It is essential that proper aseptic techniques be followed. Keep the top over petri dishes or tissue culture plates. Transfer viable material as far back in the biosafety cabinet as possible, and always recap vials. Work with one specimen at a time and recap before going on to the next. Discard empty tubes immediately. This will minimize contamination of your work. If a spill should occur while working in the cabinet, cover the spill with a towel and soak with a 10% bleach solution. After allowing 10 to 15 minutes for contact time, wipe the surrounding exposed surfaces and equipment with an appropriate disinfectant. After cleaning up a spill, discard your gloves and replace them with a new pair. Allow the cabinet blower to run, purging the work zone for several minutes. And be sure to autoclave all contaminated materials. After completing your work, run the biosafety cabinet for 2 to 3 minutes without activity to purge the air. Disinfect the outside surfaces of all items to be removed from the biosafety cabinet. Place all waste in the discard container within the biosafety cabinet. Remove, discard, and then replace your gloves. Then remove all the items that have had their surfaces decontaminated. Remove any waste and disinfect and autoclave or place in the appropriate waste stream. Disinfect all biosafety cabinet surfaces, including the work zone side and back walls, and the front sliding sash. You should also periodically decontaminate under the front air grill. Once the biosafety cabinet is appropriately disinfected, turn off the lights, the blower, and shut the sliding sash. Degown properly by removing and disposing your gloves and removing your lab coat. Wash your hands and forearms with germicidal soap and water. If you perform higher risk activities in the cabinet in a biosafety level 2+ or 3 laboratory, remove your outer gloves and then your gown, being careful not to contaminate your skin or your street clothes. The outer gown and gloves should be disposed of as biomedical waste. Wash your hands thoroughly with germicidal soap and water. ESCO Micro is headquartered in Singapore, a Southeast Asian city-state bordering with Malaysia, and has manufacturing facilities in Indonesia and sales and support offices around the world in the USA, Latin Americas, China, India, and the Middle East, with a combined workforce of 300 employees. With a stable management since 1978, ESCO is a highly focused manufacturing company with a long-term commitment to the industry. ESCO's products are manufactured to cater to the needs of two main niche market segments, the laboratory market and the clean room market. Today, ESCO's products are distributed in over 70 countries and are being used in thousands of laboratories and clean rooms around the world. Some of the success factors that make ESCO a leading manufacturer in the industry are a comprehensive and vertically integrated manufacturing facility, extensive in-house research and development laboratories, products certified to major international standards, such as the US NSF 49, ISO 9001 Certified Total Quality Management System, ISO 14001 Certified Environmental Management System, ESCO consists of 5 core business divisions: the Biotechnology Equipment Division, the Fume Filtration Division, the Laboratory Fume Hoods Division, the Clean Room Construction Components Division, and the Clean Room Equipment Division. The ESCO Biotechnology Equipment Division is a manufacturer and exporter of biosafety cabinets, laminar flow cabinets, and other specialty clean air and containment cabinets for the laboratory. ESCO's Fume Filtration Division manufactures and exports ductless fume cabinets for the laboratory, with products designed to meet the requirements of major standards in the industry. The ESCO Laboratory Fume Hoods Division is an exporter of laboratory fume hoods compliant to the ASHRAE 110. ESCO also manufactures construction components for the clean room, such as fan filter units and clean room air shower units. ESCO also manufactures clean room equipment, such as modular soft or hard capsule clean rooms, laminar flow systems, and garment storage cabinets. ESCO's Clean Room Apparel Division has one of the most comprehensive range of products in the industry and has many years of experience providing clean room laundry service locally. ESCO was founded in 1978 as ESCO Technologies and has been a pioneer in clean room technology in Asia. ESCO was the first company to develop and build a clean room for the electronics industry in Singapore. And starting from the 1980s, ESCO has been exporting locally developed and proven clean room technology. In the 1980s, ESCO was one of the first to start using the latest mini pleat HEPA and alpha filters. In 1982, ESCO designed and manufactured the very first Class II biohazard safety cabinets in the region. Starting from the middle of the 1980s, ESCO has introduced many technical innovations to its products, including auto purge slots on laminar flow cabinets and secondary isolated negative pressure filter seals. In 1997, ESCO's manufacturing plant was relocated to Bintan Island in Indonesia, allowing for a significant expansion of factory space. ESCO made its first export sales outside of Asia in 2000 and has since then expanded its business focus towards the global market. In the subsequent years, ESCO had its products type tested and independently certified to major international standards, such as the Australian Standard for Laminar Flow Cabinets, European Standard EN 12469 for Class II Biosafety Cabinets. In addition, ESCO's quality management system has been certified to the ISO 9001 and ISO 14001 standards. Since 2003, expanded research and development facilities have been established. Today, ESCO is the only manufacturer with products certified to all key international standards for biosafety cabinets and laminar flow cabinets. ESCO is an export-focused company with active sales and distribution in over 70 countries around the globe. To date, ESCO Biotech products have been sold in over 74 countries, and active sales and service distribution networks have been set up in 70 countries. ESCO's Class II biosafety cabinets have been type tested to the European Standard for Biological Safety Cabinets, American Standard NSF 49 for Class II Biological Safety Cabinets. In addition, ESCO laminar flow cabinets have been independently tested by the Australian Standard for Laminar Flow Cabinets. ESCO Biotech participates regularly at international trade shows, and ESCO products are displayed at many regional and local shows by our distributors. Quarterly training seminars are held at ESCO headquarters to instruct distributors on servicing and selling of ESCO products. Regional distributor workshops, as well as end-user training workshops, are also regularly organized during trade shows. ESCO is a corporate member of the major industry associations. ESCO currently employs one of the largest and best equipped research and development teams in the industry. Our research and development team consists of specialists in all fields relevant to production, and currently 1 out of every 3 non-production staff at ESCO is employed in a research and development related position. Our in-house facilities include a controlled environment sound insulated test chamber with HEPA filtered laminar flow, exhaust system, and adjustable lighting. In-house wind tunnel for the development of airflow sensors for biosafety and laminar flow cabinets. In-house KI discus containment test equipment for biosafety cabinets, and ASHRAE 110 containment test laboratory for fume hoods. Fully equipped microbiological laboratory for challenging biosafety cabinets with bacterial spores. In-house decontamination chamber for performing decontamination cycles on biological safety cabinets. Performance testing conducted on all produced ESCO products include tests according to relevant international standards. These may include airflow velocity testing, aerosol challenging of filters, operator comfort tests, and electrical safety tests. Additional tests are performed on ESCO products, including the KI discus containment testing and microbiological testing. Computational fluid dynamics software is used to visualize and analyze airflow within the cabinet based on whichever optimum cabinet design is produced. ESCO employs BioCoat antimicrobial powder coating on its lab culture range of Class II biosafety cabinets, which ensures contaminant-free surfaces. ESCO's 42,000 square foot manufacturing facility is located on Bintan Island, Indonesia. ESCO's production facility currently employs the latest state-of-the-art sheet metal fabrication machinery, in-house powder coating line, and a sophisticated array of performance testing instruments. In producing an ESCO biosafety or a laminar flow cabinet, raw sheet metal is first sheared and punched according to the drawings, which are programmed into the machines using computer-aided manufacturing technology. The cut sheets are then bent on computer-controlled hydraulic press brakes. Bent parts are then welded together using a suitable type of welding technology. After welding, the parts are polished and ground to remove imperfections, and regular steel parts are pre-tested for the powder coating process. Thermoset powder is sprayed onto the panels using an electrostatic spraying machine, and fully coated parts are then quality inspected before being cured in an oven at around 200 degrees Celsius for 10 minutes. ESCO has an in-house test lab to perform tests on the resistance and durability of the powder coating. At the end of the powder coating process, products are inspected for imperfections. The main assembly process receives parts from sheet metal, welding, and coating departments, as well as from external suppliers for items like hardware, blowers, and filters. Other parts, such as electronics panels, are manufactured in a sub-assembly line. All electrical modules are tested for safety. During mechanical assembly, the cabinet body is carefully sealed. All components and hardware are then installed on the cabinet body. After assembly, all cabinets go through a final electrical safety test. Then they are moved into the testing department for relevant performance testing for each model. Products are once again quality inspected and are packaged to be sent out to customers around the world. At ESCO, our mission is to build a global brand in the laboratory equipment market. We are achieving this by building and supporting a strong sales and service distribution network in regional and local markets around the globe. Our goal is to achieve the most extensive international coverage in our industry and to establish localized presence in all major world markets, such as Europe, USA, and Japan. This is possible due to the following factors: a strong network of ESCO distributors, focus on the customers and end users, the widest product range in the industry, with continuous research and development, the most competitive prices, and larger production volume than that of any single European brand. These factors, combined, have made ESCO the clear leader in Asia today and will no doubt make ESCO a leading global manufacturer. The Lab Culture Class II Type A2 Biosafety Cabinet is a state-of-the-art biological safety cabinet designed in strict compliance with the following international standards. For Class II Type A2 cabinets as defined in the American Standard NSF 49. For Class II cabinets as defined in the Integrated European Standard EN 12469. For Class II Type AB3 cabinets as defined in the Japanese Industrial Standard JIS K3800. For Class II cabinets as defined in the South African Standard SABS VC 8041. The key features include a fully configurable state-of-the-art microprocessor control, an attractive complete stainless steel internal work zone, an ergonomic 10-degree sloped front, BioCoat antimicrobial coating on the cabinet exterior, a self-regulating airflow design that maintains safe airflow velocities, superior mini-pleat ULPA filters, The Lab Culture Class II Type A2 cabinet uses the latest design ultra-low particulate air, or ULPA filters, with the typical efficiency of more than 99.999% at 0.12 micron levels. ULPA filters are able to provide 10 times better filtration as compared to conventional HEPA filters offered by other manufacturers. As a result, Lab Culture cabinets are able to provide a work zone cleanliness level of ISO Class 3. Complete cleaning is simplified with a stainless steel internal work zone. The cabinet's internal sidewalls and the back wall are made from a single sheet of stainless steel, a unique feature which eliminates any welded or sealed joints which may accumulate contaminants. The front air grill is a single piece with the work surface. The BioCoat powder coating on the cabinet exterior dramatically inhibits the growth of bacteria, thereby ensuring no cross-contamination occurs due to contaminated surfaces. The diagram illustrates the effectiveness of BioCoat against control samples of E. coli and Staphylococcus aureus, commonly known as staph bacteria. The Sentinel microprocessor control has a default warm-up cycle of 3 minutes, during which time the cabinet work zone is purged of all possible contaminants. Audible and visual alarms alert the user of unsafe conditions, such as when the sliding sash is at an unsafe opening height, which may cause airflow disturbances. The front sliding sash is made from a shatterproof laminated safety glass. Should the front sash be broken, the loose glass shards are held together by the laminate adhesive, ensuring operator safety as well as containment within the cabinet work zone. The stainless steel armrest is raised above the work surface, which ensures that the operator does not block the inflow grills while working in the cabinet. The air inflow grill design is curved to prevent objects from causing disturbances to the air intake. Lab culture cabinets may be fitted on site with accessories after purchase. No modifications to the cabinet body are necessary. Simply install the accessories in the pre-fitted provisions. All cabinet provisions are pre-fitted with the user in mind. For example, the service fixture provisions are staggered in order to provide easier access to both service fixtures. The cabinet is designed with a 10-degree sloped front, which provides better visibility into the work zone. The microprocessor control panel is downward sloped for easier access to the control buttons from a sitting position. The cabinet exhaust filter area is designed with a slope to prevent loose objects from obstructing the exhaust airflow. A Class II Type A2 is a recirculating design biosafety cabinet. This means that room air is drawn into the cabinet through the front air grills. And travels below the work surface through the back of the cabinet and into the blower plenum. From the blower, the air passes through the OPA filters. Approximately 30% of the air is OPA filtered and exhausted to the surrounding environment. The remaining 70% of the air is ULPA filtered and recirculated back into the cabinet work zone as unidirectional or laminar downflow air, providing a sterile and non-turbulent work zone environment. Close to the work surface, the downflow air splits, a portion entering the front air grill, while the remainder enters through back wall perforations. All downflow air is then recirculated to the blower plenum, along with inflow air. The following experiment with a smoke generator illustrates the airflow pattern in a Class II Type A2 cabinet. Downflow airstream splits and is taken in through the back wall perforations and the front air grill. This feature ensures that the airflow streams remain unidirectional and free of turbulence. The enhanced side capture zones between the sidewalls and the work surface eliminates the possibility of the downflow air bouncing off the work tray and creating turbulence. For additional safety, the lab culture cabinet side walls are fitted with side perforations behind the sliding sash to remove possible turbulent air pockets from the work zone. A smoke generator placed near the sidewalls illustrates the airflow into the enhanced side capture zone and the sidewall perforations. Lab Culture Class II Type A2 biosafety cabinets are equipped with the Sentinel microprocessor control system. All control features and functions may be configured to suit the user's requirements. Cabinet airflow velocities are continuously displayed on the LCD screen. The Sentinel control provides intelligent hardware diagnostics and generates error message reports. The control system monitors blower usage hours to gauge ULPA filter lifespan and alerts the user when a replacement is required. Cabinet airflow velocity settings may be calibrated directly from the microprocessor control system. For security purposes, access to the cabinet's menu and operational functions may be restricted by setting password locks. The laboratory supervisor may use this feature to restrict cabinet access by unauthorized personnel. The ultraviolet germicidal lamp on the cabinet control system is interlocked with the sash window position for additional safety. This means that the UV lamp may not be activated unless the front protective sliding sash is fully closed. The UV lamp is automatically deactivated once the sash is even slightly moved from its fully closed position. The UV lamp is installed out of the operator's line of sight, ensuring protection to the operator from direct UV radiation. For service personnel who require the cabinet alarms and interlocks to be deactivated for maintenance purposes, the cabinet control system can be set to a special maintenance mode. Protected by an administrator password, this feature is designed for use by service personnel during cabinet decontamination and other service procedures. The work tray is radiused at the edges for better containment of spillages and allows for thorough cleaning. A small handle is provided on each side of the work tray for convenient removal. The drain pan is a single piece, which permits easy cleaning with no hard-to-reach corners. The drain pan surface is sloped downward to direct fluid spillages toward the drain pan valve. The front service panel provides service access to cabinet modules. It is easily opened by removing the screws on both sides. Parts that are potentially contaminated and hazardous, such as the blower plenum or the electronics electrical module, are color-coded red to advise caution. Fluorescent lamps are installed outside of the work area to minimize obstruction to the downflow air in the work zone. This design also ensures that the light does not shine directly at the operator. The Lab Culture Class 2 Type A2 Biosafety Cabinet is certified and tested by independent test bodies to major international standards for Class 2 biosafety cabinets. The cabinet offers numerous user-friendly features such as a sloped front design and enhanced cleanability. The microprocessor-based control system provides the user with full monitoring and control of the cabinet performance. Superior design OPA filters provide ISO Class 3 air cleanliness within the work zone, ensuring the best product and operator protection as well as environmental protection. The self-regulating cabinet airflow system ensures the best performance as the filters begin to load through normal usage. These and many other features make the Lab Culture Biosafety Cabinet an optimum solution for biosafety requirements of your processes and applications.